Greetings, welcome to day 71 of projectDIG. Thanks for joining. projectDIG is a 2D multiplayer automation survival sandbox game that I'm developing entirely here on Twitch and uploading all the VODs to YouTube. So we're making a custom C++ game engine and currently focusing on Tilemaps, trying to get them just like the data supported, and then actually rendering and displaying all of the tile maps, all the tiles. Sorry, just getting started, waking up here. Haven't had a sip of coffee yet. So we made a ton of progress yesterday. We have our tile maps that look like this, which is just a list of tile or a vector of tiles. And then we have a tile which contains like the ID and then a few bits of other information for displaying it and the quantity, track how much there is inside of a single block or tile. And then we have our tile data, which is what we ID into, or like the ID is kind of like the index into the tile data, and that contains all of the data for the actual tile. So lots of data here. That's the same for all of the tiles that come from the same prefab type. And then we have a bunch of functions to help us manipulate that data or get it. And now we're working on the draw function, actually displaying it. Oh yeah, that's the stuff. Okay, so yeah, that's what we're gonna do today. Tile data, tile stuff. Should be fun. I think the thing that we need to figure out right now is how do we want to, like, we'll start with a really basic version of all of this. Go ahead and close some of these files that we don't need at the moment. So I'm kind of thinking about supporting a function that we can call that takes a tile itself. I think I might do that. Maybe. I think there's two ways we could do this. One is use a vertex array. Well, we should do whatever's easier to start with, because I'm not sure if this is going to even be able to handle it. We'll need to do some stress testing here. So yeah, we could use a vertex array where we put all of the data into a vertex array. So that would mean that we need to batch things on the tile side, which might not be a good idea. One thing I really need to do is like get the viewport from the render system. Like we have the renderer here. Yeah, I'm not sure about that. Anyways, so one way we could do it is the vertex array. That would require us to pack up all of the data and batch it together, because we wouldn't want them to be individual vertices. Yeah. The other way we could do it is to do something kind of like our sprite function, which what it does is it figures out the texture and the program that's for the shader stuff and creates a unique ID and then batches those the sprite by that special ID. So we're creating these groups, and everything within that group, everything that has the same UID, a group UID, can be batched together. And so we could do the same thing with our tiles, where anything that has the same texture and the same shader program can technically be batched together. So we batch them here, and then, or we like put them together there, and then down when we actually draw them out, we batch them together. So what's the data that we actually need to be sending? I guess it's the position and the tile, huh? Too bad that those are like separate. I wonder like, so yeah, I don't want to try to pre-optimize this, although I have a feeling I am going to need to optimize it. Let's try to keep it as simple as possible to start with. Right. So what I could do is there's like texture data. It could do something like tribal shape or texture data. What's the actual information that we need to provide? I guess the texture rect, the sprite, and maybe the color. Hey, High Tech with the sub. Welcome to the siege. Hey, thank you for the support. Thanks for using your Twitch Prime here. Appreciate it. Hope you're having a good Sunday. Yeah, so Maybe what we could do is have the special type in here. We could even just have it in the C++ side of things, since doesn't look like anything else well, actually I take that back. We need to store it in probably one of these vectors. So yeah, I'm thinking we could do something like tile, well, we can't call it tile data. We could call it tile render data. I don't know. So that's a work in progress. So what do we actually need to provide, or like pass in? So I'm thinking that this might end up having the shader information. So we kind of need both of these, right? Well, to pass into the function, we need to pull out the frame, which will get the text direct. What else do we need? Technically we don't need the texture because that's being stored in the, like, the texture handle and the program are both in the group UID. We could put that in there. This is one thing where we're going to have a map and we probably don't want it to resize. Yeah, we were doing that before. So we'll have like tiles. This is going to be a tile render data. That all looks good. Let's actually move this down. So what else do we need? Texture, program, text direct. I think that's it for now. We could add in a color later if we wanted to, like support tinting or something like that. It's really simple. It's pretty much vertex data, right? Width and height. Vertices. Width and height. What's that width and height about? Text direct. So that should be good. So what I'm thinking then is that we'll have this function, we'll just add it to the bottom, we'll call this, we'll have a tile, and we'll have a tile data. And then we also need the position. Wait, do we actually? That's the tile vector position. I guess we could do that, and then we need to convert it into screen space though. That shouldn't be too bad. Let's try that out. So that's our function that we'll be calling. Since we added that in, we do need to kind of add in a few things here, or say that there are a few things. Oh, you know, it's, yeah. Struct tile data. We know what a tile, or yeah, a tile vector is. So then this is one thing that kind of sucks, is then we have to include the tile in here. I guess it's not that bad. Yeah, not sure about that. I could almost see an advantage to kind of flipping it where we pass in the tile render data to the draw function, and that's it. We have a text direct. Okay, so yeah, that's one thing that's wrong here, is that I actually need the position, huh? Kind of forgot about that. The text direct, that's where it exists on the texture. We also need the position. I'm going to go ahead and say that the maybe we'll do it like that. I'm going to go ahead and say that we will never want to stretch it, because I don't think we will. If we did want to technically like stretch it or anything, it would mean that we need to support or have this be a pixel rect as well, and have it be like the area. But we'll just use the text direct width and height for that, so it's always a 1-to-1. Yeah, I think I'm going to pass in a tile render data, and that's it. I think I like that more, because then that means that our render system doesn't need to know anything about tile, which I would say is a good thing. So we'll go ahead, yeah, so that will end up just being tiles. I guess we do need to calculate the group UID, which will be something like that, right? Texture resource. Oh, I guess that means we also need to get the texture resource. It's up there. Unless I store the texture resource, I guess I could do that. Yeah, let's texture handle. Wait. Texture resource. Resource. Oh, that actually contains the pointer to it. Texture resource. Contains the resource handle, as well as the width and the height of that texture. Okay, so actually, in that case, we have tile.texture, which is the handle, so we can just do the IDX. The tile program IDX. And the program, yeah, so that's all fine. Okay, that works. So that's a group UID. And we need to, oh, whoops. I did that wrong, huh? This needs to be a vector. Can I do a move of the tile? I'd like to do that. Can I do it like, what's the proper way to do that? I think maybe like this, which says, hey, let's take, maybe. I'm a cucumber, please don't send me to the pickle factory. Your secret's safe with me, Pickle Rick. I mean, cucumber. Yeah, so I'm not sure. Let me look that up. I haven't done that much as a Gown Geek. Sender, or maybe I should do like C++, move, operator, I'm not super, move assignment, function parameter, like this. Keep a copy, don't keep a copy. I'm pretty sure that the compiler will do that automatically. That's what I'm trying to figure out right now. Pass by value and move over pass by reference. I guess that's what I could do. So that's what I was doing. A past R value binds to R name, then is moved into M name. Past L value, past R value. So it seems like I could just do the move, I think. I don't know. I don't know if I'm actually saving anything. Yeah, I'm still trying to figure out exactly how this works. So I could do it like this. And then what if I call the pushback move? I'm not sure if that works. I'm still like trying to understand how, yeah, vector, or maybe I should say move into vector. That it may steal. Interesting. So that does make a difference. Okay, okay. So yeah, maybe we'll do it like that. I think this might be the right way. So we create the group UID, or we calculate it, and then we move that tile data into our tiles. I'm just trying to avoid like copying this a lot, this tile render data, because we don't really want to do that. Hey, Colt. Paint me like one of your French toasts. How about a French roast? Coffee. Okay. So yeah, what we will end up wanting is a tile rendered data that we then do a draw function and we pass data. Right. It says it does not match tile rendered data. Wait, what? This should work. Oh, I have data overloaded. Render data. There we go. That will work. Okay, so that means that now we need to populate our render data. So what is render data actually composed of? We can look here. It's the texture, the program, the texture rect, and the position. Hey, Centipede Kid, what am I working on? I'm working on this game called projectDIG. It's a 2D multiplayer automation survival sandbox game. Think Factorio meets Terraria with physics and yeah, making a custom C++ game engine. Currently working on making it so we can render tiles. If you have any other questions, you're more than welcome to ask. Okay, so yeah, we need to get, so here's where like the texture rect will be. So we can get our data. Texture should be a resource handle. It is. So we can say resource, get texture. Texture resource. Think I have to now include resource. And so with our texture resource, we can do some stuff that looks like this. So it kind of sucks to have to do this for every tile. Maybe it's not so bad. Do I have a function that just says like, hey, get the program? Thought I kind of did, but maybe I don't. Basically this. Maybe I need to implement that. Yeah, perhaps I should implement that. Wait, and then it can return it? Because I do that in several places. Yeah, I think I will implement that function where it needs to be able to create the program if it doesn't exist. If it does exist, then it should just return it. Yeah, let's do that. So we'll do a little bit of refactoring here. So oh, we actually just get the handle directly, sure. So what we do is we say, hey, if this doesn't exist, if this texture doesn't exist, like it hasn't been loaded yet, then return. So that's one thing I'm kind of considering, just trying to scrap. Like maybe we shouldn't check this. Maybe we should just assume that it does always exist in this case. So then we could get rid of that conditional, that branch, which would be nice. What we could do is an assert log instead, just assert that it's valid. Our tile textures should always be loaded before we try to render. Oh, whoops. That's kind of wrong. What is this? Tile texture not properly or not fully loaded before we render it. And I guess we can, we have our tile data, right? So we can say data prefab ID. And if we really want, we can say prefab get. I can get the prefab from that, right? Prefab, oh, it's prefab dash name. There we go. So that will tell us exactly which tile we're trying to use that's invalid. So that will only occur on debug mode. Otherwise, like, this will be removed. Let's see here. What else do we need? So we can get rid of that. Oh yeah, that's right. We need to get. What's the texture? Okay, well, if we're going to do this with no branches, then we can just set this up here and say, hey, this is our render data texture. And, oops. Then we also need to get our program. Here we'll say render data texture rect. And we do need to like figure out how we're going to do that. Let's go change the program. So the program's the shader program. Basically that's the vertex shader and the fragment shader combined. And we have to create a program for BGFX, our render, to be able to actually render things. Let's so I do need to have it. I think what we'll do is like say get program, and it will take our two. Should we just pass in? I think what we'll do is we'll pass in these, which is resource handles. So we'll say resource handle vertex shader. and fragment shader. And then we want to pretty much just have that. So this program, this just checks to see if it's already set. We'll end up we'll still keep that part. Okay, update, shutdown. Let's see here, draw, render. I think we actually just want to stick it here. Oh, that's wrong. What's our program handle actually? It's a program handle. Surprise! Render system get program. And so I believe we just want to do this. We'll get rid of that and that. Let's see here, fragment shader dot handle. So that should be fine. Oh, it's my bad. Those are resources. So I need to say this is like our vertex resource. Resource. Do we just use the handles and that's it? So maybe what I should do is change it, because that's a it's just a shader handle. Okay, yeah. So maybe we could say these are shader handles, and we can just do handle, vertex handle, fragment handle, dot handle, dot handle. So we get the handles, and then instead of doing all of that, we can just replace it. And then same deal with this. So we just make sure that they're valid, and then we create the program UID. We look to see if that program already exists. If it does exist, then what we want to do is actually return it here. Return that. If it does not exist, then we want to create it and then return it. So what we'll do is a program handle program. We then add it to our programs, and then we want to return that program. So why does it not like this? Shader handle is not defined. Really? Oh, it's BGFX. I see. I need to actually. There we go. Resource handle. That should be good. Oh, I forgot to say that it returns a program handle. So now we have that all set up. So instead, so like here, instead of doing all of this, what we can do is just say, hey, let's get the program for our vertex shader. Or wait, no, it's going to be render.vertex shader and render.fragment shader. And that's it. And then all of this is bye-bye. And we can do the same down here, right? So why is it? So I say in here, if it's invalid. So I guess I assume that it's going to work. But then why here do I not? Oh wait, hold up. Oh, this is a problem. See here, this is returning, and these shaders are not loaded yet. Yeah. I see. Dang, that's kind of annoying. Because it does mean that then I have to have like this other check. Yeah, it was I should have realized that. So I could return an invalid pointer. This is one thing that kind of sucks about allowing for resources to be loaded. Like, we render them or use them whenever they're available, and if they're not available yet, then we just like we're cool with it. That means that every single time we try to use it, we have to check to see if it's used or if it's available. Where it'd be kind of nice to be able to just be able to assume that it's available, because it's like 99.9% of the time it's available. It's only like maybe the first check or two that it's not. So, like one thing I could do, I guess this could work, is have another check in here, which just says, hey, like get the program, or yeah, try to get the program. If it doesn't exist, or if we fail to get it still, then return. So I might like keep trying to do this. Most of the time it's going to succeed, so then at least we have this check in here. This does kind of suck though. And basically, it's going to fail if these are invalid. One thing we could do is move this part out if we really wanted to, and then just pass in the shader handles instead. It does mean that suddenly now we're having to handle this part as well. So in this case, we would want to say it's an invalid. Oh wait, what do we set it to? Yeah, BGFX invalid handle. So then, yeah, if it's invalid, we can just return. So that would be the same thing here then. Like that is doing exactly this. So we would say, yeah, we kind of, I don't really know how much we're saving here. So we can do that. So we have to say, oh, this is spine program, this is spine, this is spine, this is spine. So we are saving a few lines of code. Well, we're saving all of that. I mean, we're not having to do that over and over again. Here, this is the sprite program that we need to be setting. It's the same thing. Sprite. And then delete that. Here, oh, draw. For this one, I actually collapse it down, interestingly. So what we can do is get rid of that. And then say get program, program. Vertex, wait, what was it? Vertex array, yeah, okay, that's what I thought. Vertex array dot vertex shader fragment shader, and then we don't have to do this part, and we can just say if the BGFX is valid program is not valid, then we want to return. Hey, Ocker, what's up? Hello. Yeah, welcome everyone. Thanks for joining. Okay, I think we might be done there. What we could do is look to see if we are doing anything like calculating the program UID or just actually using programs, period. Should tell us, yeah, that's it. Okay, cool. So now that we've done that, we can go over here and actually get it. And I guess again, we're going to just assert that it exists. So that's going to be render data program is our resource get, or not resource, let's renderer get program. And we're going to, yeah, we're going to need to get our vertex shader from our data, I think, and the fragment shader. Hey, Ocker, yeah, I probably can help you out really quick. I was using Catch 2. It's not too hard to set up. I can show you. So I take it you are using Visual Studio. So we need to add these in. So this should be, oh, it's this vertex shader fragment shader. And right now what we'll do is we'll just copy that data over from our renderer here. Vertex shader. And maybe we'll change it in the future or something. Yeah, I'm not completely sure about this. Like for Korea, what I did is I had it so that the wall layer actually, or the wall map had a different shader than the ground layer. And so maybe we want to do something like that. I'm not sure yet. So we might want to end up changing these. Maybe. So that's the texture, that's the program. We have to get the text direct. And then there's the position itself. The position is going to just be the render data position. I think what we can just do is create it from this, right? Which are the position as a position, or sorry, a vector. So that will convert it over. We might not even need to do it like that, right? Like, can't I just do this and it will cast it? I think so. I should be able to do that. So it will, like, this is a tile vector, and this is a position, and so whenever we do that, it will actually end up multiplying all of the values by the size of the tiles, which is right now 16. And then, yeah, we need to set the text direct. So before I do that, let me help Ocker really fast. So pretty much what you need to do, yeah, so you can add a new project. You want to actually have it be an executable that it's generating, so an application. and then you set up just like what you would with the game or whatever the main thing is that you're compiling. And so what I did is I actually have it so it's using that library. So it's kind of like I have the main library, which is a static lib. Yeah, so, or you can have it be a DLL if you really want, whatever, it doesn't matter that much. But you have the library that has all the like common code, and then the main game application is just like, well, what I do is I call into it. You can have whatever data you want in there, but anything that you want to be shared or used in both your the game or the testing needs to be in the common library. So yeah, you kind of set it up exactly the same. And then in order to test this, what you can do is you only need CPP files. And so they have one thing in here, this define catch config main, and that just tells it to create a main file, just like a main function, just like what you would have in here. So that's what that does. You define it, and then in the catch.hpp, it actually makes it. And then, yeah, you just have these test cases. Yeah. So, if that's, yeah, that should be enough. You can see this in one of the YouTube videos that I made, which would be quite early on. We did testing, basic game testing. I think it's this right here. Copy link address. Yeah, exactly. Yeah, so you could check that out. I think that's where we did it. And then also, and just in case you didn't know, you can get access to the source code, which contains all of this, and it's under MIT license if you are a patron. Just saying. But yeah, another way you can see the code is just looking at the video. Yeah. So yeah, that should hopefully help you out. It's pretty easy to use. Catch is nice. I like it. It's super useful. Yeah, no problem. Okay, so render data. Yeah, we want to be setting the texture, but we need to figure out this whole like frames thing. That's right. We don't have that set up whatsoever at the moment. Have any of the game up and running yet, or are you still on mostly the engine? I'm still mostly on the engine, but we do have some things of the game. I mean, like, there's a thing. It is a thing. Let's see if it actually runs. Why does it? Oh, it doesn't like running because. Yeah, I should have realized this earlier. It's because I need to update the data. I should have realized that it's whenever I try to run it from here, it's trying to use this. This is the working directory. Yeah, there we go. So yeah, we have like some UI here. We can kind of have it make sounds. And we can create little entities. Oh, that's not working. Huh. I wonder why that's not loading properly. But yeah, so we have a few things set up there. But it's not like an actual game. We're starting to get close to it. Still better than Fortnite, yeah. So you can see if you go to that digseedsgame.com link and then click on the roadmap, you can see this page. And so you can see that we have a lot of the engine at least like kind of set up, and we're getting close to actually doing gameplay stuff. Like this tile map is actually somewhat game related. It's not like a game system like crafting or anything, but it's moving in that direction. Okay, we need to add in this frames thing, or this like concept of the frames. I think right now I might just hack it. Heck it. Because I just want to, let's just try to get something rendering and then we can go from there. Let me open, oh wait, we might already have this open. We have one of them. Yeah, so I think what we could do, actually maybe I do need to open up dirt specifically. There's our dirt. So what we could do is use this right here. 271.1. So yeah, if we really wanted to hack it, what we could do is just say, hey, this is a text direct. (271.1) 16:16. So that's like super hack. You wanted hacking, you got it. So one thing we could actually do is, and this would require us loading it up. What we might actually want to do that during like the pre-processing or something. There you go. Okay, nice. Glad that those videos actually coming in handy. That's cool. I like that. It feels good whenever someone's like, hey, how did you do this thing? I'm like, you can find in this video here. Unfortunately, if the videos are quite long, they're not like as concise as it we would like, but it would be a lot of work to break things up. And also I do jump around at times. Okay, so I think that should be okay. Respect the viewport and only draw. Yeah, there's a lot of things that we can improve upon this. But let's just start with this and see if everything is building. So SGDQ is over. Crazy. What am I gonna do? I actually didn't watch that much. I watched maybe like half a day worth or so. Pretty cool though. I was watching some, what was it? A little bit of Chrono Trigger run last night. That was cool. That was like the finale or close to it. Okay, so we're just trying to compile here. Doesn't like, this is UN32, and what is this? Tile vector is an N32. No, yeah, it's an N32. No, it's a, yeah, that's right, N32. The width. Okay, so I guess we can just make that be an int. Maybe we'll never actually have it be different, but we'll never have it be negative, but this will just make that go away. Okay, so yeah, let's see. What we'll probably want to do after this is we could actually figure out the correct frame information and the variance. So I actually had it automatically figure that stuff out in Korea. Because if we look at our texture, we can see like, well, we know how big our text or the images are, right? So we can see like, hey, this is I think we always have like a slight buffer around them. I forget how much. I think you have to actually specify, or there's a set amount. It's like, well, I think in this case it's 1 pixel. So they're 18 by 18 since it's a 16 by 16 plus 1 pixel buffer or like border on each side. And then so it's 18 by 18 plus also another border just to go around everything, right? Or actually in this case I guess not. It should be though. This really should be a 20 by 20, but right now it's 18 by 18. And so we say, okay, let's divide the height by 18, and that will give us how many variants we have. So we would have 3 variants in this case. And we have them all set in the same like order. And so we calculate the frame based off of that. That is all happening inside of here. We have the frames figured out, and so we'll have to do something like that. Calculating the frame. One thing I did is I made it so that it didn't have to do that every single frame. It would only do it whenever it was updating. It would be like lazy. It would only calculate it when it was rendering and rendering it for like the first time or something. Maybe we'll do something like that as well, if we need to. Did this compile? It's still compiling. So yeah, we could figure out all of this frame stuff at runtime. It'd be nice to actually calculate it not at runtime, but later. Such as yeah, the thing that sucks about that is we need to know the height of the texture, which means we need to load it, and that sucks. So if we had that being calculated and stored in somewhere, that would be nice. I don't know how feasible that is. It's something I'm kind of considering doing, is maybe making it so that all of our prefabs oh, I can close this. Let me close that. Let's open up a prefab. Dirt.prefab. So here's our dirt right now. So what would be cool is if we, instead of having all these prefabs, it kind of condensed everything down to just like a prefab database that contains all the prefabs, and maybe it actually contains the information on the prefabs, but it could figure out some additional things such as the text direct for this, or the you know, maybe it could look at the actual texture that we would be using and see, oh hey, this is the size, these are all the different frames that we should have or something. I don't know, it's a little tricky because I definitely want to support having the prefabs be in individual files. So because I don't want to have to recreate the prefab database every single time while I'm testing the game or adding in new prefabs. So I want like this debug version or something that will try to do that stuff, but then it also supports like having all that stuff be automatically loaded. Or like predefined, and so that's a little hard. A success. Let's try to run this and see what happens. Oh, you know what? I forgot to set. Thank you. We forgot to do this. That does, yeah, it's something that will probably take me a while to get used to. We need to set the empty tile and also the deleted tile. Sorry, that's wrong. Okay, so I realized that I don't actually try to render this. Whoops. So we're doing everything except for whenever we call the submit layer, we're supposed to be trying to like draw this, kind of like the sprite, but we're not. I really feel like I need to refactor this because this is kind of silly how many of these I have here. And they're all very similar where we have like, here's our tiles, this is out of all of the tiles. If the tiles is empty, we continue. Yeah, like most of this is the same. Tiles, tiles, tiles. We have the texture, tiles. Texture handle to resource handle, that is, so we actually already have it, right? Oh, yeah, the texture resource is, texture resource. Oh, interesting. Well, that's not needed because we have the texture rect. Yeah. Oh, wait. No, we do need... That's right. Forgot about that. Ugh. I forgot about that. Okay. Actually, I messed up a little bit. We are storing the texture resource handle here. I can't do that. Tile data. Oh, I need to go to our render data texture. There we go. This needs to be a resource handle. Which does mean we'll probably need to change it up above. Texture. Up here. What is going on? Why is it doing that? Right? Or actually, wait. It's in here, huh? Texture. The resource handle. No, we don't want the resource handle. We want the texture resource. That's what we want. That's what we want. Yeah, that should work. Handle. Okay. That looks better. Build failed. Oh, here it stores the width and height. I see. Interesting. It's so annoying how you have to have that. I mean, I get it. It's just annoying. So this doesn't know what resource is. It doesn't include resource at the moment, which is why that's not working. I mean, I guess that's technically the same, right? Just doing it like this. It's the same amount of data. Maybe I will do it like that. So it's all together. Handle. Okay, so then let's see here. What does this need? This needs the handle, right? Not quite. So what we want to do is say texture resource is equal to this. And then, so that's our texture resource. And then for this, we want to say, oh, that's the handle. Kind of exploded out. I'm not sure how much I like this. There's no attribute texture. I'm pretty sure it does. It's right there. Technically don't need that. So now that is our handle. Okay, so that's all good. We go back down here. Now we actually already have our texture handle. So yeah, I don't think we need that. Texture resource. This is going to be, let's see here. So this is tiles, tile. I believe we can just say tile. Texture, right? We could definitely save a lot of data if we change that. Actually, I just realized something, that these handles are uint 16, so I should probably keep them together. But like, I could take out that data. Like, this is a uint 32 basically, or a byte worth of data that I could technically calculate in here pretty easily. So we don't want that anymore. This is tiles. So we do a bunch of stuff here. Make it so that if we kind of hit the maximum number of vertices, then we we submit that and then start a new submission. But yeah, you can see that this is really doing pretty much the same thing. Texture resource. So that will just be tile width as well, right? Which is... yeah. The origin, we don't need to deal with that stuff at all. The SRT, I don't think we need to deal with that at all. Unless we're like wanting to be able to zoom in and out of the entire world and have that happen here. Maybe we end up wanting to do that. Here's our model. SRT. There's our position. So really what I just want to do is translate it, right? Right now. So like I could say model origin SRT. I think there's a place where I don't support that, right? X and Y. Yeah, I think we want to simplify it down to be more like this. I'm gonna copy that. So yeah, this is tile position. The width and the height. That should just be... wait, width and height, width and height. Oh, we have that be a fixed size. Right. Well, we'll just use the... that's right. We just want to say this is the texture rect width and height. Yeah, that's what we want. And this is tile width, tile height. So that should all be good. We don't actually have color stuff right now. I mean, I suppose we could just add it in. So color is equal to color white. And this code is definitely ugly. I need to clean it up bad. Okay, so this is once again texture resource handle. Yeah, that's really just tiles 0.texture. Same with this. tiles 0.program. And then down here, we want tiles clear, no resize. Because we will likely be using it all again. So we don't want it to be resized. All right, I think that will work. Definitely need to refactor this code. It's absolutely a candidate to be refactored. I need to figure out how though. How do we refactor this? Seems like we have about like 5 or so pieces of information that we're really using. Like the texture rect, the width, the height, the color. I guess there's some, like in this case, there's a little bit more information. Like the scale, the angle. The texture, this. Yeah, there's just a lot of information. The number of vertices. Hey, Fibers. How's it going today? It's good. It's good. How about yourself? All right, build success. Oh, gasp. We have some tiles being rendered. Only one strip though, interestingly. But that's pretty awesome. So why is it only one strip though? But hey, it's kind of working. That's awesome. Oh, this is technically wrong. That should be height. Right now, that's the same, but yeah, that is wrong. So that's the index. Sure, I mean, they're all the same, right? We can scroll through this. We see that they're all set to 1. Woo, tiles! Yeah. Yay, something is rendering. That's actually awesome that I rendered the first try. I was expecting to do some, well, kind of first try. Kind of. Hey, Cooler. What's up? Kind of. Plus plus y, so that's right. I am curious what's going on here. Oh, it should be doing y's first, right, and then it does x afterwards. So what I'm really interested about, I guess, is this. Wait, what? Yeah. Oh, there it goes. Oh, my bad. I see what's wrong. I forgot to set it back. That is important, isn't it? Yeah, this needs to be position.x or y is equal to 0. And this also needs to be changed to height. Should I be setting position.x equal to 0 here too? I guess it doesn't matter since it's the outer loop, but it doesn't hurt anything. Okay, there we go. Hey, Fargo! Welcome back to the Siege. Thank you for the continued support. 7 months, nice. Got several subs today. That's awesome. Thank you guys. I really appreciate it. It's a lot of fists. Oh, it's breaking. Hello? What's going on? Visual Studio freaking out. There we go. Hey, look, our tiles. It's rendering. Woot woot. Nice. That's cool. That's a lot of fists. Hope all is well with the new project. Yeah, I mean, just look at this. Just look at it. It is. It's coming along. This is. I'm quite happy about that. Be interesting to see what it looks like with a larger tile map. Let's go ahead and do that. Let's go to our game. And let's say 256 by 256. That should take up the entire screen, plus some. So 256. Oh. What happened here? Did we run out of max indices? What's going on here? It seems like it was too large. Index. So it's trying to allocate this transient buffer. It says number is 0. Wait, what? How did that get to 0 though? It says that the tile is 65536 and this is 65317, so it should be like 200 and something. Right? But requesting 0. That seems to be the problem. I'm not sure how that got to be the case. What is tiles? What size? Oh, it might be that there's too many tiles inside of that group. That seems a little weird though, right? Yeah, that seems wrong. That one box, yes. Thank you. We spend a lot of time working on the UI already. But we have something set up, so it's mostly working, which is awesome. Okay, so I'm trying to figure out exactly what is going on with this. Why is it trying to... Um, 651... Like, why would it say 0 here but not in here? Something is off. What's this index? Index is a uint32. What's the size? Is size... It's a size t. That's a uint as well. Okay, let's try to help ourselves out here a little bit. Let's do this. Let's say uint32t remaining equals this. Then we can just say remaining times that. So then we should be able to see what it's complaining about more specifically. Okay. Yeah, we'll just do that. I mean, technically we don't need that static cast, but whatever. Okay, crash, 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 crash. Yeah! Remaining is 219. But here it says it's 0. That doesn't make any sense. This must be calling get available transient buffer. Check 0 is... This isn't debug. Why am I not seeing it calling this though? What must be happening is that it's running out of buffer, vertex buffer. Okay. That has to be it, is that somewhere along this chain of calls, it seems to be like, I don't know, doing something. Why is it, I don't get this. I'm not seeing it calling this function. I say get and it's calling allocate. Allocate. So it must be in here. Allocate transient buffers. Okay, so what's happening is that we're running out of transient buffers. Am I not freeing it properly or something? I'm doing something wrong here, so we need to go look at our BGFX. Try to figure out what's happening. returns the number of requested or maximum available vertices. So we need to kind of look at our buffer stuff and see how we can use that. Set index buffer, set index buffer. Set index buffer, draw primitive. I'm trying to see allocates the transient buffer. It's filled and is valid for the duration of its frame, and it can be reused for multiple draw calls. So that's the thing I don't quite get. It says, and it can be reused for multiple draw calls. So can I, let's just try this and see if it like works. Is say, so we submitted it here. We set the vertex buffer and the index buffer. With our index buffer, there's the data, the handle, the size, and the start index. I'm wondering, like, can we just clear it? I don't think so, but maybe. Get available. I don't think we can set it. Or maybe it gets cleared whenever we submit it. I doubt it, but maybe. Let's look at how this is being used. So we set the transient index buffer here. If we go to where this is being called, set the index buffer. Code handle. This code is kind of complex to read. It looks like it's calling this dynamic. Oh wait, no, it's not. I don't actually know where it's setting it. Maybe it's down here. Coder. Okay, I guess it's in it's not in these functions. I see. So we set the index buffer. Yeah, I would have to look at the source code, I suppose, to figure this out. I don't know if I'm going to be able to figure that out here. Like, this code is quite complex. I'm not super familiar with BGFX, but we can look. Let's look for our submit function. Yeah. There's our index buffers. I don't think I'll be able to figure that out. I don't know if that's really the best way to try to figure it out either. I mean, we can try doing this. I'm pretty sure it's just not going to work. what we'll end up seeing is like only some of the tiles being rendered because we keep overriding the vertex and index buffers. I'm guessing that is what will happen, but maybe it will actually work. Shapes. So it ends up running out over here. Must be doing something wrong. Dang. I'm trying to think about the vertex buffer. Seems like it's only happening with our index buffer. Dynamic index buffer. Buffer index 32. Did notice that it was hitting uint 16 max. Wonder if I need to do something like that. Allocate. One of the possibilities is that I'm only using transient buffers, and maybe it's really like limited on how many transient buffers it can use, and I could use other type of buffers like a dynamic buffer. Dynamic index buffer. I don't know if that's really. I guess we should try to figure out what the exact error is that we are getting. Maybe I could try breaking here. Let's go ahead and stop. Okay. Oh, it's just that the tile size is, yeah, 256 by 256, I see. So, remaining size index. So we got almost all of them in here, but it seems like we just ran out of space. The index buffer. Max indices. There's a lot. And it seems to be okay with our vertices. I guess that's because we're only taking 4 of them, whereas for the index buffers we are using a lot more. Oh, dang it. For some reason I thought, oh, no wonder. I was trying to allocate here. Oh, duh. Max vertices. Wait. Transient vertex. Oh, it's the vertex buffer that's dying. I thought it was our... Oh, that's what I was screwing up. Yeah, it's our vertex buffer. My bad. Yeah, it says max vertices. That... Yeah, that's it. It's saying 0. It's like, I can't allocate anymore. Okay, let's reload that and try again. And actually step into it properly this time. So here we go into there, we say yes, the number is greater than that. That's good, let's step into that. Oh dang, I don't have... BGFF. I don't have this file. It doesn't know where this file's at. Yeah, I don't know about doing the disassembly stuff. Yeah, it doesn't know how to find that basically. But what it ends up doing is returning um yeah, hit 0. Okay, so our vertex buffer is the thing that's running out. Imagine both would. Yeah. I must be doing this wrong. Must be doing it wrong. So now we can just try like 200. I definitely need to try to fix that issue. Yeah. We can see our frame rate's at 4 now. That's awesome. That'll tell us exactly where we're spending all of our time. Here's this draw function. Draw, yeah, it spends 40% of its time. Spends a lot of its time. So this tile draw is where it spends a lot of time in the program, Git program. Which is kind of crazy. Like, what is it doing inside of there that's taking so long? Oh, it's just doing a lookup. That's right. Yeah. Then it spends a lot of its time pushing the tile back. It's doing a lot of tiles, to be fair. That's actually the majority of the time it spends is doing that stuff. Has like the pushback function. Here's in place back. So it's just adding it. Get a shader. So like one thing we could do is like if we like one quick optimization we can make is actually doing this outside of this for loop. Such as when we are setting this up, if we, instead of getting the fragment shader and the vertex shader, if we got the program while it was adding it, I don't know if it's actually fully initialized at that point. I think it might be. Or just like one really quick way to do it would be to get the program here. Right. Thinking. Yeah, I think we could just do that. Program handle. It does mean that we need to, like right now, it would mean that we'd have to have the same shader stuff, but that's not a big deal. Like, we go to our vertex. Right now, we're always using the same one, so we could just do something like this. load it. So that will return that. Fragment shader. I think we could technically just do that. That gets us the program. So then, and here we can just say render data program equals program. There's a lot of things we could do to optimize this. I'm just, yeah, we'll take it one step at a time. Oops. But hey, we got an extra 2 frames. The biggest is like it's recreating this data every single time. That's like where almost all of the data is coming from. Like you can see 80% of it is happening in here. So it's spending a lot of time getting the texture resource, and then it spends almost all of its time trying to draw that tile. Yeah. 50% better, that's right. The thing is that this data is not changing very often. So and this pushback is kind of ridiculous. Yeah, I think it's just, it's not, what we might want to do, so we have batching. So batching is very good to do. So we want to batch, but the thing that sucks about this is that we're batching, or we're like pushing back onto this vector. So we're having to like reallocate and resize this every single time, which is super wasteful. Yeah, I honestly think that what we're going to need to do is like have it be, probably do something like what I did for Korea, more of where, yeah, unfortunately make it a little bit more complex. Well, let's think about it. So it would be a huge win. I knew that this was going to be slow. I knew it. I just wanted to see what it looked like. Actually, one interesting thing. We can talk about it, but while we're talking about it, let's actually run it in release mode. I'm just curious to see what that looks like. So obviously the majority of the time that it's spending a lot of time in the draw function. Let me actually just do this. So adding this tile, pushing it back onto this group, doing all that stuff. Like this is right now, like it's all the same tile, so it's really simple. Like the only thing that's changing is the position. And that's actually a really good point, is that the only thing changing is the position. So like all of that data is the exact same. All of that is the same for every single one. The text direct technically could change. The position and color could technically change. Like we probably could get rid of the color. I don't think we actually need it. But the size of the data, that doesn't matter too much anyways. So like trimming this down isn't going to make it be that much faster, if at all. But right now, like we know that they're all the same group ID. What I'm just thinking is we could like dash this sum. So what I did for query is I broke it up into segments. And just like if you're caching things, that's typically the best way. You know, if you, and I said this I think yesterday, typically in order to gain speed boost, you need to cache stuff instead of recalculating every single time. So and that's what I did for Korea, is we need to stash some of this or cache it. So how can we cache it? You know, anything that's cached, that means that it might become outdated, and so we need to keep that cache up to date. So what I did for Korea is that I had this concept of segments, and so I take the world and I break it up into segments where it's like every 16 by 16 tiles is considered a segment. And if that segment has data that changes, so like if we ever set a tile, then that tile's segment, the segment that that tile belongs to, needs to become invalidated, and it needs to recalculate all of the data that's within it. And technically, if a tile changes that's on the outside, on the edge of the segment, then the neighboring segment should also change. So like I don't really have, we'll just do something like this. So let's pretend that this is our segment. It's not going to be evenly divided. That's okay. Oops. Let's move that up a little bit more. We can split that a little bit more evenly. Okay. So it might look something like this. Like I said, it's not even. That's okay. And so these are our segments. So like this would be 0, 1, 2, 3, 4, 5, 6, 7, 8. Like that's how we can index them, just like that. Or we could do it the other way, going across this way, but whatever. So that's how we can index them, is it would just go down, like wrap around, or this way, whatever. Doesn't matter too much. And so what I'm saying is that if we ever have, let's say, this specific tile right here change, then that means that we need to reload this entire segment, or like recalculate the cache data within it. If we change the tile like right here on the edge or whatever right here, then that means that we need to actually recalculate this one as well as this one. And I guess if we ever change the corner one, then it needs to recalculate all four, just because that means that technically it could change if like it's trying to wrap or something. And so if we're doing that, then and so yeah, that's what I did for Korea. And so I would calculate the frame based off of that. And the frame is our text direct that we want to be using. So then, let's see here. What can we actually cache? So we could have this concept of segments, and the segments could contain what would it be? So yeah, what I did for Korea, and this worked, I ended up having it be very fast. So this might be like a really good solution. I did spend a lot of time thinking about it. But basically what I did is I have this concept of segments, and then a segment, so we have some like hash map segment ID to the segment data. And the segment data contains it's another hash map of the tile ID or the tile type to the tiles that it contains, all the tile data, like the tile render data. So that way we have them all grouped up already. So then all we just need to do is and it might actually just be best to do that is render them like that and not worry about batching them all together. That is a possibility that you could go through them all and then like append. So each segment would say, okay, this is a segment. It contains dirt and stone and clay, and each of those would have their own list of tiles that they are in, like the tile position. The tile position and tile, I guess it's just the tile render data, right? So then what we could do is to say, hey, let's render that, the tile render data, and yeah, so we could just render that. We could, if we wanted to, try to batch them together. So we would say like, hey, let's get all of the dirt from this. And it technically should not be using the tile ID, but actually the program UID or whatever, the group UID, which is the texture and the shader. And so it would group them together, or it'd have the group UID, and then it would say, hey, all the let's just say that right now each tile is its own group. Say, okay, let's render all the dirt for all of the visible segments, and then all of the stone for all of the segments. Or it could just say, let's render all the dirt for this segment. Let's render all of the stone for this segment. Tilemap. Yeah, we're doing Tilemap rendering right now. It's not very helpful. Nightbot, huh? Hey, the Delmega, what's up? So, yeah, we could try to batch all of the segments, or we could do the individual segments. It's definitely important to be batching it. I don't know how necessary it is to batch all of them. Like if we think about it, let's say that I have it up over here. Let's say that we have our screen. Right now we'll just say we're 1080p. So that's 16 divided by 16. Whoops. Yeah, that's 8,100. That's right. I calculated that the other day. That's how many tiles are in the world. Right. I guess what I could do is that's how many.
Oh, no, that's right. That's how many tiles there would be, but then I need to say, hey, divide that. That's how many segments we would be seeing. So basically our screen that we would see is 7.5 by 4.2, and we probably just would round up. So it'd be about 8 by 5. Bro, what's up? What design patterns do you use in your project? Mostly going for data-oriented design. Trying to avoid object-oriented as much as possible. Just like to try to change things up. So yeah, mostly I'm trying to do data-oriented. It's new to me, so I'm probably failing to some degree. And then also we have like entity component system, and a few other things, yeah. So we have, it's about an 8 by 5 or 40. So that would mean that we'd be making 40 submits for all of the tiles. Or I guess that's not true. If we do want to try to batch the tiles up into similar textures, and that would be a big, like, for every single tile that's not batched up, it means that we would have to do an extra draw call for that segment. So if we had 2 different draw calls we're having to make, or submissions, then it would jump up to like 80, which isn't horrible, but it's definitely getting up there. So yeah, it might be worthwhile trying to combine them together. Is this open source? Kind of. I am streaming all of the development, and it is available and under MIT license, but you have to be a patron on my Patreon to get access right now. There's a goal, kind of far away right now, but there's a goal to make it completely public. You're new? Yeah, no problem. Yeah, I figured. It's cool. Welcome. So I could see that working. Yeah, we might want to batch it. How would that work? I guess what we would need to do is go through all of... So the reason why we want to batch them by segments is because then that's fairly easy to try to recalculate. We know like what we need to invalidate and where everything lives. And then also one thing I did for Korea, which was pretty cool, is I had this concept of like the segments that we had calculated, and then it would invalidate it over time. So let's say that, um, you know, your character is like over here, and so your viewport might look like this or something, or that's actually a lot of the space, huh? Okay, let's just shrink it down. Let's say that this is your viewport. So this is what you can see at the time being. So we're just zooming in essentially. And so that means that it needs to calculate these 4 segments, everything that your viewport is touching. And then as you move, let's say, your viewport's going to be moving as well, then it's going to start calculating. So it will like create this and cache it, create this and cache it, create it and cache it. All of those will be created and cached. As you move, it will start updating or like calculating and caching these other segments, all of the tile data for those. And it will keep these around since, we already did all the work. But after a while, I think like once we have some threshold, we start to delete. I think what I actually did was I would I think I would just clear it out after we hit some threshold and say, okay, we should start over. what would probably be better is to have like a timestamp on it or something, like the last time we used it. And what we could do is go through and purge any tile maps that are after some age or something. That might, I think that would be better. I mean, the segments that would be, you know, maybe older than 30 seconds or a minute or whatever. It doesn't need to be too long. So just if you're like moving around, like maybe you might be like straddling, like you're on the edge, like, you know, if your viewport is right here, then you're now getting all 6 of these. But if you are like moving just like back and forth between here, like you're zigzagging or whatever, it might be like, oh, you need these and now you don't, and now you need them and now you don't, and now you need them and now you don't. And it might be the same for these over here, and so we would want to keep them around since you're like continually using them. But if you first left from over here and then you came over here and started zigzagging, you know, after a minute we'll decide, oh hey, you actually don't need these segments anymore, you're not using them. Or if you were X segments away, yeah, the distance could work as well. I think yeah, distance could work for sure. Time or distance, either of those. And we could also just do it once you hit a certain threshold. Like, you know, we could say, hey, you can keep around like 30 tiles or something. Or 30 segments, or maybe more. I mean, it really depends on how many we're using, how much space it is, whatever. But once they hit a certain threshold, that's when you could start culling them and say, okay, we hit, you know, 200 segments. Let's go ahead and remove and get down to like 128 or whatever. And so we just like iterate through them, and or I don't know, or maybe at that point that's when we're like, okay, we know that you couldn't have seen that many segments within the last few seconds, so let's you know, at this point go and cull everything that is older than a few minutes or whatever. And so basically the idea is that we just want to cull the segments at some point because you know, they're going to be taking up space. Trying to build a 2D game, and it took me 5 hours to figure out how to create a tile map, and I still don't know what to do with it. I spent like several hours working on the tile map too. That's what I've been doing the last few days, so you're definitely welcome to check out the VODs. I haven't uploaded them to YouTube yet. I will be doing that hopefully later tonight, but you can check them out here on Twitch. Yeah, Tilemaps can be tricky, for sure. Especially whenever you're like trying to render a lot of tiles and you need to really optimize it like this. Just because there's so many. I knew that this was going to be a problem. So really what would be best is if we cache the data and we cache everything that is like as close to BGF as possible. Like, one thing we could actually do that would make it really fast is, what if we allocated a static buffer? So we can go look at that. Index buffers. Yeah, so it would be a static index buffer and a static vertex buffer. There's dynamic. Dynamic. Where's the static one? Static vertex buffer. I thought that was a thing. Great vertex buffer. Maybe it's just that. I'm trying to find where it actually talks about that. Dynamic vertex buffer. Be nice if they actually talked about oh. Interesting. Okay. This might be part of the problem why we're running into yeah. But I think once we do this, might be better. Update dynamic vertex buffer. Like maybe what we want to do is use a dynamic vertex buffer. That's probably what we actually want to do. So if we have a dynamic vertex buffer, then what that means is that we can actually be updating the vertex and the index buffers directly. And so what our segments could contain is that information, all of the actual buffer that we would be passing over to our render system. And so it'd be very fast. It does mean that so whenever we would recalculate, we'd have to recalculate that. Or what we could maybe even do, update dynamic vertex buffer. Yeah, that's probably what we would want to do. So we can allocate some BZFX memory, which would contain all of our data. Yeah, I think that's what we'd want. And that's where yeah, I'm not sure about that. Looks like the vertex buffer is always static. Wait, our vertex buffer is always static? Why is that? It technically, well, it depends on like if we have a dynamic vertex buffer, which I think is what we might want to use. Update dynamic. Why can't this find stuff? Dynamic vertex buffer. Set the buffer. Create. So yeah, we can have it so it is using memory. So we could just be changing whatever the memory is, it sounds like. I don't quite get this. I thought PGFX. I don't know. I thought there was some information on this. Definitely don't want that API reference. That's what we're looking at, right? I thought there was more information about this. It said it was static when looking at the docs. Okay, maybe the non-specified version. Gotcha. If we go to the API reference, go to resources, vertex buffers, create vertex buffers. So this must be the static. Yeah, okay, yeah, sorry, I did miss that. So that creates a static vertex buffer. Yeah. But then you can also create a dynamic vertex buffer. Gonna empty dynamic vertex buffer. Yeah, there's somewhere, I remember reading somewhere where it actually like went over what this stuff means. Like what is a dynamic versus a static versus a transient. I can't find that right now. What I recall is like it goes in that order. So a static vertex buffer does not change. Or yeah, like never changes. Whereas a dynamic vertex buffer like barely changes, but it does change occasionally, or it can change. Whereas a transient vertex buffer is like it's changing every single frame. That's what I recall it saying. I need to look around for how this stuff should be used, but I think what we probably want is, well, either a static vertex buffer and maybe a dynamic vertex buffer if like what we're saying is, oh yeah, we want to be able to change it. Yeah, I don't know. One thing we'd probably also want to do is just recycle our yeah, I think we'd want to do that is recycle our segments. So if we ever like end up using up a segment, then we just say, okay, let's clear that out. And so maybe what we would actually want to do, I could see this working out. This actually, yeah, this sounds good. Is that we can have an interaction where we say, like, hey, this is, we would have a map of, and this is kind of what I did for like for our component pools, where we have a hash map that is the segment ID. So that's a unique segment ID which points to an index. So the value is an index. And then what we can do is have a pool of segments that we are using. And so we have like a pre-allocated pool of segments, and we're like, hey, these are the segments that we would use and we would be displaying on the screen. And what we can do is, have it be larger than what we would need to be able to display on the screen, so that way we can kind of keep around some. But then what we would do is just use that, and whenever we're done with it, we just like swap it or whatever. We know which ones we're using, which ones we're not. Maybe we could keep an empty list of segments around if we don't want to have to move things. We could just say, oh yeah, this one is free. That's what we did with our resources, I believe. Our entity IDs. The entity indexes or indices. Yeah, so I think that could work. And so that way we're not having to reallocate that data every single time. We're just reusing it. Keeps a static amount of data around, which is good. It does mean that sometimes we'll be using more resources than what we actually need, but I think that's okay. Static should be things that never change. Dynamic should be things that sometimes change. Transient should be things that change every frame. Yes. Yeah, so I think what we want most likely is our dynamic thanks fibers. Where did you find that? You want to link that? So yeah, our I'm thinking what we'll want to do is have something, I'm just gonna sketch it out here, which would be some like struct with our segment data. I don't know what exactly that is. That's okay. And then we will have a hash map that is our segment ID, which is just a, well, I'll get to that. And then this could be a uint. I don't know. We probably won't use more than 256, so we'll just say a uint 8. That should be fine for the index. Maybe we want it to be just the size t to make it easy, whatever. That's our index. It also makes it clear that that's the index. So our using segment ID is equal to just that probably needs to be a uint32. Just doing that so it's clear, like, hey, this is a segment ID to an index. Segment indices, or I don't know, whatever. And then what we would also do is have a, we could do like a static array of segment data to some maximum number. I mean, we say, well, I was saying 256, but we could do like, yeah, a uint 8. Or if we wanted to, we could do a static const, uint a, I don't know, max segments. Segments max. So like this. And so if we ever want to get the segment that we're using, oh, and we probably would also need a vector of segment, or I guess it would be the indices, right? This would be free segments. And so what we would have is, like, whenever we'd start, maybe we'd also want the count. This is kind of weird. Maybe I need to think about this some. Like, one thing we could do is to say, hey, all of the segments are free. That is a possibility. Where we just push back all of them. Maybe. I don't know if I like that. Another possibility is that we could have the segment count. I don't know what I like more. I don't know, something like that. We might need to push back all of the segment ID, or all of the indices, the possible. So it'd just be like, you know, for uint 8 t I equals 0, I is less than the segments max, and then free segments push back I, and we could say, hey, the size should be segments max. So then actually what we could just do is to say I is equal to I, right? So we're just saying, hey, they're all free. And then what we could do is just like pop them. Hey, thanks, Fibers. I appreciate it. So yeah, we would pop them as we use them. And so if we want to use a new index, we would just say, hey, you know, like, if, you know, if the segments is empty, then we need to, you know, clean up. Otherwise, well, we'll assume that we clean up so we always have some afterwards. And then we would say, hey, let's just like pop the back. And that's our index. Oh, it's a size T. Let's do that. And then back. Oh, whoops. I need to say back. And then we need to pop it. I forgot that it doesn't return. This thing getting it returned. So that removes it from the back. I mean, we can also pop the front, right? I think popping back is better though. If we have a, yeah, I don't know. It really doesn't matter too much. If we wanted a deck, we could use that instead. But anyways, so continuing to kind of just sketch out what this could look like. We, if we needed to get a segment, we would say, okay, here's all of our segment indices. So, you know, we have some segment ID, which would be calculated with, like, let's say that we had a tile vector position is equal to, 82, 34 or something like that. So then we take the position, and I might honestly, we might want to make a function that does this for us, like this, converts a tile position to a segment if we are using this in many places. But it could be something like position.x divided by this, I think I have the sizes segment, right? Segment tile. So this would say, hey, figure out which segment this belongs to, right? And then it needs to be, oh yeah, that's right. So we actually need to know the size of like the world at this point. Well, I think we have the size of the map. So we technically, I guess, have that. So it might be something like this position.y divided by the sizes segment tile times the map. We don't have the map at this point, but it would, let's just pretend we have this like world dot segment or something, segments width. So that doesn't actually exist right now, but let's just pretend that it does. So then we could say, hey, get the segment ID, and then we could just even directly use the result from that, which is the index, to get our segment. So then we can say segment data, segment is equal to that. So that's how we could access it. So this just makes it so that way we're able to easily reuse this data, but also be able to quickly get it. So this does do a hash map lookup, but that's okay. What I did for Korea is I actually made it so that we iterated over the segments. So we calculate the segment ID, and then we'd get all of the tiles within that segment, and so that's how we're doing it. Hey, Bob the Builder, what's up? We are working on this game, projectDIG. We're currently doing Tilemaps, Tilemap rendering. Figuring that out. That's what we've been working on today. So it looks, I can actually comment that all out. I don't think I've actually changed anything. Like, it should still work, right? It's really slow because, oh, that's right. I was trying to build release mode. And it seems like release mode doesn't want to work. Interesting. Why is that? I forgot that I was trying to build release mode. We'll see if it works. Recompile standard out. Why is it not? It doesn't have that anywhere. Yeah, I'll have to recompile the prefab. I'll let it do its thing though. So unfortunately, I'm gonna need to be going here in just a minute. but yeah, I was going to try to let this compile. So tomorrow I'll be back. We'll be working on this more. Hopefully we make some good progress with it, where we actually are getting it all set up and rendering much more performant. So we have like the baseline 4 frames a second, not bad. We got it up to 6 with a small change, but really that we could do so much more. Yeah, the more we cache, the faster it's going to be. It's just more memory that we're having to use. Does mean that we're going to have this like idea of like these segments. This kind of sucks. Yeah. I think we're going to need to put this data on the tile maps as well. So these here actually are going to need to live within the tile map in here. That's what it will be cached because it's per tile map. And yeah, so we can look at what the Korea one does. Here you can see like we figure out, yeah, here it actually like clears up the segments and everything. So then we iterate over all the segments. So this rectangle is actually a segment rectangle, I think. How many segments we're using? Yeah. So that's how many segments we are using. And so we have the starting segment, and so we just kind of go over from segment to segment. We're like, hey, let's do this segment, and then do this one, and then do this one, and then that one, and then we're done. And so it goes over those segments. It figures out like the actual segment ID, and then we figure out like, hey, is this let's actually get the segment ID. I believe here it is, the true segment. Yeah, we do a bunch of stuff in here. Here it actually sees if the segment vertices. Yeah, this is where we're like, hey, have we calculated the segment vertices, which is like all the rendering data. If we haven't, then let's actually do that. And I don't know what this add change segment is. Yeah, there's a lot that happens there. It's very complicated. Okay, I think it should compile now. I think that was the one file that had an issue. Can't believe these compile times already. I feel like I completely failed at trying to make it so that the game was faster at compiling. Makes me sad. It's so slow. I think it's just my use of templates. I kind of regret you going so template heavy. It's just silly how much time we waste every single time we want to compile. What are you doing? I guess it hasn't actually done this for quite some time, so yeah, MSVC kind of sucks, honestly. Like, it's always so slow compared to the other compilers. What is it doing? This project isn't that big. I'm starting to think it crashed or something. It's definitely working hard. Or is it hardly working? Yeah, it's trying to link everything. Dang. What the heck? That's longer than it takes for it to link Korea. Something must be wrong. Right? Okay, it said I had to redo 93% of the functions. Let's see. That's a lot of functions. See, is that 80, 90, 100? Oh, dang. We're speeding along. We don't need to record. That's cool. Yeah, I mean, there's still a lot of improvements we can make. But yeah, it's crazy the difference between debug and release. On debug, we're getting 6 frames. That's it. 6. I bet by the time we're done with this, our debug will be still well over 100 and like 100 to 200, and our frame rate will be like, our FPS should be probably 6 or 800. That's the goal at least. So yeah, there's a bunch of tiles being rendered. This is our test UI. And yeah, so that's great. So yeah, we're just going to be working on trying to optimize this tile rendering because it needs a lot of work. So that's going to be it for today. Like I said, tomorrow I'll be back 8 a.m. Pacific time. You can see my schedule down below converted into your time zone. I'll be working on trying to optimize this. If you're not following already, feel free to follow. And if you are watching on YouTube or are not subscribed to my YouTube channel, you're welcome to subscribe there. And I'll see you guys tomorrow. Have a good rest of your day. Take care.